Hi everybody, it's Dr. Bardo again, and we're going to do more with area. The first formula we're going to talk about is a brand new way to find the area of a triangle. And this uses the fact that from SSS we know that once we have the three sides we have define the triangle. There's only one shape it could be, and so the area must be able to be found from the three sides without any angles involved at all, and not the height or anything like that, just the three sides. So Heron's formula is a formula that was known to the ancient Greeks. Heron was an ancient Greek, and it's kind of complicated, but it works. And I won't go through sort of why it works right now, but I do want you to be aware of it. So the first thing to solving a Heron's formula problem is to calculate something called the semi-perimeter. So you probably know how to find the perimeter. You just add up the three sides. To find the semi-perimeter, you add up the three sides and you divide by 2. So it's half the perimeter. Semi is a prefix that generally means half. And then once you have the semi-perimeter, you're going to multiply 4 numbers together. You're going to multiply the semi-perimeter, which you just found, the semi-perimeter minus one of the sides, the semi-perimeter minus the second side, and the semi-perimeter minus the third side. You're going to multiply those 4 numbers all together and then take the square root, and that will be the area. So let's do an example. Here's a triangle that we know and love quite well. It's the 3, 4, 5 triangle. That means that we know that this angle here is a 90-degree angle probably. But let's not use that. Let's just use that we know the three sides and try to find the area, which I think should be 6. So the first step, of course, is to calculate that semi-perimeter. So I'm going to say S is equal to 5 plus 4 plus 3, which is 12, all divided by 2, so that's 6. So the area is going to be the square root of 6 times 6 minus 5, which is just 1, times 6 minus 3, which is just 3, times 6 minus 4, which is 2. So we get 6 times 1 times 3 times 2. That's the square root of 36. That's equal to 6. So it worked. Huzzah. Now that we have Heron's formula in hand, we can use it to actually find heights. And so we have these two different ways of finding the area of a triangle. One of them is to, if you have the height, you can take it times the base. You know, the area is 1/2 base times the height. But if you were dealing with a triangle in real life, actually finding the height is quite hard, because you'd have to sort of know how to go exactly straight down. If you had something in real life, that could be kind of tough to do. It'd be a lot easier to just find the three side lengths and then use Heron's formula. And what this tells me now is that I can find the area 2 ways. I can use Heron's formula, or I can use the 1/2 base times height, or I can use Heron's formula to find the find the area. Then using the area and the fact that I know this base here, I can find the height. And that's kind of the question I'm going to want you to do coming up here, because it can be very difficult to find this distance from a point to a line, and this is kind of a cool way to do it. So here's the situation we want to deal with here. We want to find the distance to this point from this line, and we have sort of a triangle set up here, so we're wondering how big is that distance there. And so the first thing we're going to do is calculate the area. So we'll need the semi-perimeter, which in this case is 9, because it's 18 divided by 2. So the area is equal to the square root of 9 times 2 times 3 times 4. So a little calculation. Tells me that that is 14.7. So 1/2 times 7, which is the base, times the height, is equal to 14.7. So I'll take that at 14.7, I'll times it times 2, and divide it by 7, and I get that the height is 4.2. So 4.2 is how far this point is from that line. And this is so just review what we've learned today. We learned Heron's formula, which is that the area is equal to the square root of the semi-perimeter minus one side, semi-perimeter minus the second side, semi-perimeter minus the last side. And we use that to find the distance from a point to a line. I hope your chairs are going well, and I'll talk to you soon.